Okay, class, now we come to objective 5. Determine the most efficient method for solving a linear system. The three cases for system of equations and two variables. We have this case, one solution. What it looks like when you solve it algebraically. What I did here was I used the addition, or as we know it also as the elimination method. I had x plus y equals 7, x minus y equals 9. Then I added the two equations together, and I ended up with 2x is equal to 16, divided both sides by 2, and x is 8. Then I went and substituted in 8 for x, and I had 8 plus y equals 7. Subtracted 8 from both sides, and y equals -1. So my ordered pair is 8, -1, which is my intersection point, which is represented here. I just did a sketch of different points here to show the two lines intersecting. Okay, now we go here to the next case, no solution. Okay, no solution. I did it like this. I used the elimination method again, and I had -2x plus y equals 9 and 2x minus y equals 8. When I add these two equations together, -2x and 2x is 0, y and a minus y is 0, and 0 plus 0 is 0, and 9 plus 8 is 17. And we know 0 does not equal 17, and I give a visual representation of parallel lines that indicate no solution. Now, scroll down here. We have all real numbers. And I need to add one other thing to this here. Is all real numbers, or you could say infinitely many solutions. Okay. Now, what we have here is 2x plus y equals 8 and -2x minus y equals -8. When you add all these together, you have 0 equals 0. Now remember, as long as you have a number equal to itself, there's always all real numbers or infinitely many solutions. And that's represented by one line because both of these graphs will overlap each other. So it would look like one line, but it's actually two lines just overlapping each other. Okay, now we go on to the next page. It says here, comparing solution methods. Okay, we have different methods here we've used. We use graphing, that was from section 4.1, and then from sections 4.2 and 3, we use substitution and addition. Now we're going to look at the advantages and disadvantages. With graphing, you can see the solutions. The disadvantage, if the solutions do not involve integers or are too large to be seen on the graph, it's impossible to tell exactly what the solutions are. Remember the last problem we did from 4.1 where the solution was outside of the graph so we could not see the intersection point? That's a major disadvantage, and we won't even talk about if we ended up with decimals or fractions. We wouldn't be able to tell what the answer is by simply graphing. Now we go to substitution. Substitution gives the exact solutions. It's easy to use if a variable is on one side by itself. That's the advantage. The disadvantage, solutions cannot be seen, can introduce extensive work with fractions when no variable has a coefficient of 1 or -1. When they're talking about the extensive work, it mainly goes like this here. If you end up with some fractions or some decimals, you can end up having to do a lot more work to find out what one answer is and then solve for the other. Now the addition method, or we call the elimination method, it gives exact solutions, easy to use even if no variable has a coefficient of 1 or -1. And the only disadvantage is solutions cannot be seen. Now, there is one other disadvantage. If you have a problem with the least common multiple, then you may have a little difficulty with the addition method. But if you don't have any trouble with the least common multiple, then this is the only disadvantage you will have, that the solution cannot be seen. Now we scroll down here to objective 6. It says solve problems using this it's supposed to be substitution. This is a typo. It says using the substitution or addition method. Example 11. Let L be the amount of student loans in billions of dollars at T years since 2000. The following are reasonable models for private loans and unsubsidized Stafford loans. We have private as L is equal to 3.0T minus 1.0, and L is equal to 2.3T plus 15.4. It says use substitution or elimination to predict when the amount of private loans will be equal to the amount of unsubsidized Stafford loans. What will that amount be? I think for this problem here, using the substitution method actually would be better. So what we would have to do is this here. Both of them have L is equal to some value. So all we would have to do is determine which one we want to substitute in for the other L. So what I'm going to do, I'm going to take this L here and substitute it into this L down here. So we will have 3.0T minus 1.0 is equal to 2.3T plus 15.4. Now, as always, I always put in parentheses what I substituted in. Okay, now, what we have to do is this here. We need to get all the T's on one side and all the numbers on the other. So I want to move all my T's to the left side. So I'm going to subtract 2.3T on both sides. So now we will have 3.0T minus 2.3T, which is 0.7T, minus 1.0 is equal to 2.3T minus 2.3T is 0 plus 15.4 is 15.4. Now we need to add 1.0 to both sides. And we have 0.7T. And we know negative 1.0 plus 1.0 is 0 is equal to 15.4 plus 1.0 is 16.4. Now we need to get T by itself. We will divide each side by 0.7. And we will have T is equal to, so here after we take 16.4 divided by 0.7, that is going to be approximately 23 years. Now, what we have to do next is this here. We need to find out what L is equal to. So we could take one of the two equations and substitute in 23 for L. I mean for T, and then solve for L. So I'm going to take the first equation. So I have L is equal to 3.0 times 23 minus 1.0. So we have L is equal to 3 times 23 is 69 minus 1.0. So L, we know it's an approximation because 23 is an approximation, is approximately 68. Okay, now we have the time is equal to approximately 23 years, and then also the loan amounts is approximately 68 billion. Now the question is, it says, use substitution or elimination to predict when the amount of private loans will be equal to the amount of unsubsidized Stafford loans. Now remember, this is years since 2000. So it would be 2023. We could write this out. So we can write our answer as such. In about 2023, unsubsidized Stafford loans and private loans will equal each other at about $68 billion. And that's it.